Okay, in this video we're going to have a look at what we call the extraction of metals. Let's just make sure we understand the word extraction. If you go to the dentist for an extraction, then they're going to take a tooth out for you. So extraction means removal, removing a tooth. Here we're going to talk about the removal of metals. And where are we getting these metals from? Well, in the Earth's crust, we have rocks that contain metals, and those rocks are called ores. And we're going to focus on two ores. The first one here is hematite. Hematite contains iron ore, and iron ore contains the chemical compound iron oxide. The second ore we're going to have a quick look at is bauxite, and bauxite is aluminium ore, and that contains the chemical compound aluminium oxide. And you notice that the two compounds that these ores contain, both of them are a metal joined to an oxygen. So aluminium oxide, iron oxide, the compounds containing oxygen. And if we want to make these metals useful, then what we have to do here is get rid of the oxygen, and here we have to get rid of the oxygen. Okay, so to make them useful, get rid of oxygen. If you remember from the early videos, removal of oxygen is reduction. So reduction is getting rid of oxygen, removing oxygen. How do we do that? Well, we need to use the reactivity series to help us to do this. Okay, so the first example here, I'm going to put the reactivity series underneath here so we can see this. Hopefully you can see that. You can see in the reactivity series here that I have got carbon is listed here, but I'm going to go for iron. Here's my iron, okay? So here's my iron, and here I've got the element carbon. This is unusual because it's a non-metal, but it's listed as a reference, and we're going to use that reference now. So if I have got iron oxide as my compound, what I can do is I can react it with carbon, because carbon, coming back to my reactivity series, is more reactive than the iron. Therefore, carbon will react with the iron oxide, take away the oxygen, leaving iron. That's a displacement reaction, and that will leave us iron on its own without the oxygen. Okay, so this reaction, carbon is more reactive, so it's going to take away the oxygen, leaving just iron, and that will form carbon dioxide. And the science behind why that happens is because carbon is more reactive, and that reaction is called a displacement reaction. So more reactive element is pushing out a less reactive element from its compound. Okay, and that works. This is quite a good process to use in industry because carbon is very cheap, and therefore it doesn't cost us a lot of money in order to do this process. Okay, compare this to aluminium, and if we've got aluminium oxide and reacting it with carbon, if I just come back to my reactivity series, you can see here that aluminium is above carbon, and therefore if this has got the oxygen, carbon is not reactive enough in order to do this. It will not displace the aluminium from the compound. So here, this reaction is going to be no reaction. Nothing will happen. So this is no good for us. Why? Because carbon is less reactive. So what do we do? How do we do this? This is a reactive metal. How do we separate it from the oxide? Well, what we do is the process of electrolysis. So in this process here, we are going to use electrolysis. Electrolysis uses electricity to split the compound into simpler substances. So what will form here is aluminium, and we will get oxygen. Okay, because this process is using electrolysis, electrolysis uses electricity. This process is more expensive process in order for us to do and extract the aluminium from the aluminium oxide. Both of these two reactions, just make sure we've got this, both of these two reactions are taking away the oxygen from the compound, and therefore both of these reactions are reduction reactions when we form the metal. So just to continue that last little video, here's a reactivity series, most reactive metals at the top, working our way down to our least reactive metals. And carbon here again is a non-metal, but it's a reference point, because when we have the oxides of these, or zinc oxide, iron oxide, tin oxide, and so on, what we can do with these is we heat them with carbon, and because carbon is more reactive than these metals, we get a displacement reaction and the metal is produced. The metals above carbon, that won't work, so aluminium oxide, we've already seen, will not react with carbon because carbon is not reactive enough, and therefore these reactive metals we have to use electrolysis in order to extract the metal. And the metals at the very bottom, these metals are unreactive metals, and we just find these as uncombined elements. So you'll find silver, you'll find gold on the Earth's surface. We don't have to do any kind of processing to get the gold or the silver in that way.